storing and comparing data. These are the things we are doing in this chapter. In previous section, we found the measures of center. So if you have a data, then how do you find the center of the data? And we calculated mean, median, and mode, and mid-range in the section 3.1. Section 3.2, we do measure of variation. So meaning you see, this section is going to help us to measure variation in the data. For that, we're going to calculate three different numbers: range, standard deviation, and variance. Finding these values are very easy, meaning there is a formula. You can just use the formula, or you can use a calculator, or StatCrunch for finding this value. But the most important thing from this section we have to learn is understand the meaning of these numbers and interpret them in real life situation. So whenever we have to round off the measure of variation, like standard deviation, variance, or range, then just take one more decimal place, or just follow the instruction you have given in my lab assignment. So to calculate the range, you need to find out the difference between the maximum value and minimum value. That is the range of the data. For example, I'm going to give you one example. Let's say this is the data. First of all, to find the range, you need to sort the data. And if you are doing this problem on computer, then you can use the StatCrunch or calculator to sort the data, or Excel sheet to sort the data, and that will help us to find the maximum or minimum value. In this data set, this is the maximum value and this is the minimum value. The difference between these two values is the range, which is 55 minutes. Keep in mind, the range is not resistant, meaning the outlier is going to affect the value of range. So if you have the big outlier, then that will also affects our value of the range. Okay, so these are the notation for standard deviation. The standard deviation is actually, it measures how far is your data from the center. So let's say there is a data set, and here is the center of that sample, and you want to find out, let's say X represents our data, then the standard deviation is it's the measurement of how far is this data is from the center. How do you find the standard deviation? There is a formula for that, but before that, make sure that this is the notation for sample standard deviation, and this is the notation for population standard deviation. Small s is the sample standard deviation, and this small sigma is the population standard deviation. This is the formula we're going to use for finding the standard deviation for the sample. You can also write down the very same formula a little bit differently, but they will give you the same answer. Or you can use calculator, or some kind of software to calculate the standard deviation. So one more time, standard deviation is a measure of how much data values deviated away from the center. So how much data value is, this is, if let's say X is the data value, then how much it's deviating from the center. That measurement, we can measure that thing by finding a number, which is called the standard deviation. So standard deviation is a measure of how much data value is deviated from the mean. That's the most important thing. Keep in mind, standard deviation could be 0 if you have this very same data, meaning there is no deviation. If for example, let's say this is the data set 5, 5, 5. All of the data are same, so there is no deviation, there is no variation from the center. That's why the standard deviation for this data set is 0. So standard deviation could be negative, but it cannot be standard deviation could be positive, but it cannot be negative. So keep in mind, standard deviation is never negative. Okay, so if you find the larger standard deviation, the value of H is large or high, that means you see the huge variation in the data set. So this standard deviation is also very highly influenced by the outlier, and it's the sample standard deviation, which we denote by symbol small s, is a biased estimator of the population standard deviation sigma, which means that the value of the sample standard deviation s do not center around the value of sigma. One example, where I'm going to show you how to do it using the StatCrunch. But for now, let's say this is the data set you have given, and if you want to find out the standard deviation, one thing you have to do is you have to know how to calculate it manually for the small set of the data. But while doing the large set of the data, you can use some software like StatCrunch. So first of all, you need to find the mean by adding all the data sets and dividing it by the total number of data. In this case, it's a 39.1. After that, you need to find the difference between x minus x bar. Remember, this x means each of these data value. So you find the difference, and these are the difference for each of these data values. You find the square of that, and these are the square of each of these data values, and eventually you are going to add all those square value. So I'm adding all these numbers, these numbers, I'm adding all these number, and that is the notation we use for the addition. That's called sigma notation, which is also called summation. Summation meaning you are just adding all this value, and when you do that, this is the number you are going to get. Now you are going to divide this number by n minus 1, where small n represents the data size, meaning how many data are there. In this case 11, that's why 11 minus 1 is 10. And then eventually you have to take the square root of that value, and that is your standard deviation. The unit of the standard deviation, as you can see, it's the same as the unit of the data. You can also calculate the very same thing using the different form of the formula, but eventually it's going to give you the same answer, so no worries. So the general rule of thumb, we can take it as a rule of thumb is, if you have center of the data, if you go 2 times standard deviation from that center of the data, and this value from here to here, that will be almost 95% of your data set. That's the range rule of thumb. Okay, so let's say you have a center of the population and you go up to 2 times of the standard deviation from that center to the left or to the right. So meaning, let's say the center is 5, standard deviation is, let's say, 1.5. then that means 5 plus 2 times 1.5 is 5 plus 3, which is 8, 5 minus 3, which is 2. Then from 2 to 8, the whatever value you find in the data set, they are not that much of significant. They are normal value. So anything more than the center plus 2 times the standard deviation value, that's a significantly high values, and anything less than this value is the significantly low values. If you don't have data set, if you if there is a difficulty for finding the standard deviation, then normally we can use this formula, which is range over 4, to estimate the standard deviation. So for example, let's say you have a data set, the range of the data set is 100, then estimating roughly 100 divided by 4, which is 25, would be your standard deviation. That's just a rough estimation. That's not the exact value. So one more time, if you have to find out the standard deviation for the sample, there is a formula. Sample formula is this one, x minus x bar whole square divided by n minus 1. But if you have to find the standard deviation for the population, then instead of dividing by n minus 1, you divide by the whole population size, capital N. Other than that, they are very similar, same formula. So after standard deviation, you can find out the variance, which is nothing but the square of the standard deviation. Square of the standard deviation is called variance. So these are the symbol you have to keep in mind. Notation: small h is the sample standard deviation, and square of the sample standard deviation is the sample variance, and then this is the symbol for the population standard deviation. Okay, some of the properties of the variance, it's very similar to the standard deviation. It's a square unit of the standard deviation. Like the standard deviation is not resistant. Similarly, the variance is also not resistant. The value of variance is never negative. It is zero only when all the data values are the same number. Keep in mind, this is the measure of variance. If there is no variation in the data, then the measure would be zero. So that's what it does, the standard deviation. So if you notice there one formula here, when we calculated the um, standard deviation for the population, we divide by the whole population size, but when we calculate the standard deviation of the sample, we divide by the n-1. The reason for that is when we choose the sample, there is only n-1 flexibility to choose the members for the sample. That's why we divide by n-1. Okay. If your data set is somehow bell-shaped distribution, let's say for example you have a data and you plot the data, the value, and this is the graph you get. This is called bell-shaped. Then there is a one rule. It says 68% of the data values within one standard deviation. The meaning is, let's say there is a center, then within one standard deviation from, if you add or subtract one standard deviation from the center, 68% of the data value lie under this area. 95% within two standard deviation and 99.7% within three standard deviation. This is the picture you can keep in mind. If your data set is normally distributed, this is what you are going to get. Now let's look at some examples, homework problem using StatCrunch whenever it's possible. I'm going to use the StatCrunch whenever it's possible. So section 3.2. Okay, a random sample of 10 subjects have weights with a standard deviation of 12.2733 kg. What is the variance? So keep in mind, variance means it's a square of the standard deviation. So you just take this number, which is 12.2733, and take the square of that. So that is 150.6339. 150.6339 if you round it to the 4 decimal place. It's the variance means it's a square of the standard deviation, so it's the unit supposed to be square of the standard deviation. Let me go to next problem. Let me choose problem number 5. Listed below are the numbers of hurricanes that occurred in each year in a certain region. The data are listed in order by year. Find the range, variance, and standard deviation for the given sample data. Include appropriate units in the result. What important feature of the data is not revealed by the measure of the variation? Okay, keep in mind, this is the data are listed in order by year. So if you click here, you'll be able to open the data in StatCrunch. And this is, where is that? So one more time, keep in mind, this is the number of hurricane each year. So these are the number of hurricanes. So to find the standard deviation, variance, and then range, first of all, you're supposed to know how to calculate this thing manually, but you don't have to use the manual way while doing for example, let's say while taking the test, or maybe while dealing with a very huge number of data set. So what do? You just go to the stat, go to the summary stat, go to the column, and there is only one column this time, which is variable 1, and go here under the statistics, and you can find the function you are looking for. We're looking for range, and now we're looking for a standard deviation. So just control key and then standard deviation, and then after that variance, which is control key again and variance. If you hit compute, it's going to give you the range, standard deviation, and variance. So what is the range? Range is 18. What is the unit of range? Same as the unit of the data, which is number of hurricanes. So what is the standard deviation? The standard deviation is a 6 point, if you round it to the one decimal place, it's a 6.4. And then unit of the standard deviation is same as unit of data, which is hurricanes. And then finally the variance is square of the standard deviation, which is 41.3 if you round it to the one decimal place. And this time it's a hurricane square because the unit of variance is the square of unit of standard deviation. So after finding this thing, it's very easy finding because of the StatCrunch, because of the technology. But this is the most important thing you have to focus on, which is what important feature of the data not revealed through the different measure of variation. So from what important feature of the data is not revealed through the difference of variation, the measure of variation reveal nothing about the number of hurricane area spread. The measure of variation reveal nothing about this. The measure of the variation reveal nothing about the pattern over time. What is the pattern over time? This is not revealed. So other than that, everything else can be seen in the data. Let's go to next problem. Let's say problem number 10. A group of adult males has foot lengths with a mean of 26.85 centimeter and a standard deviation of 1.24 centimeter. Use the range rule of thumb for identifying significant values to identify the limits separating values that are significantly low or significantly high. So if you go to the this is the rule they are talking about, the range rule of thumb. Anything greater than center plus 2 times standard deviation is significantly high value, and less than center minus 2 times standard deviation is significantly low value. So in this problem, we have given a standard deviation, which is 1.24. We have given the mean, which is 26.85. So if you calculate 26.85 minus 2 times standard deviation, which is 1.24, so anything less than 24.37 is significantly low, 24.37. So that's a center, mean minus 2 times standard deviation. Anything greater than mean plus 2 times standard deviation. So one more time, the mean is 26.85 plus 2 times standard deviation is 1.24. That is 29.33. 29.33. Okay, select the correct choice. Now we have to answer this question. Is the adult male foot length of 24 centimeter? 24 centimeter is less than this low value. So the adult male foot length 24 centimeter is significantly low because it's less than 24.37.